Aviation Minister Robert Kurz gave us an overall view of how the UK thinks about the decarbonization of aviation, and not just for the UK alone, but for the entire international market. And of course, United Kingdom is looking to lead a lot of this transformation and has been quite instrumental already in doing so. So this is a great session, lots of questions, and I think it was the result of this was a reinforcement of that understanding that the UK really understands the importance of cleaning aviation, really understands the types of technologies that will be needed for it, and is committed to continue pushing on it. Then we had two great panels. The first panel on the power plant side, and we had a number of executives from a variety of different types of companies. We had Glenn from Airbus, the VP Zero Emission at Airbus, providing the OEM perspective. It was great to see the view that, of course, Airbus thinks that hydrogen will be a major force in clean aviation, but also some detailization of the concepts around the hydrogen fuel production, fuel infrastructure at the airports, liquefaction, and other components of fuel infrastructure. It was great to see some of the vision for distributed production and fueling. Also, it was good to see some further details on the concepts of aircraft that Airbus is looking to bring to the market. Then we had Carl from PowerCell, and of course, there's a fuel cell company that is probably the largest fuel cell system that has flown in an aircraft, and of course, ZeroAvia aircraft. And this feat will be again repeated pretty soon with the larger aircraft, the 19-seat aircraft that ZeroAvia is looking to fly. So Carl talked to us about the key issues of adapting the fuel cells to aviation use case, including the power density, specific power metrics, and the durability, how many hours we're going to get from these systems, good references to the heavy duty cases on the ground, where in heavy duty trucks, we see 20,000 hour plus endurances of these fuel cell systems, which are dramatically higher times between overhauls than typical small and medium size turboprop engines. So this is very encouraging. Then we had Chris from ATI, Aerospace Technology Institute, that is operating the world's, what do we think, the world's most concentrated, most advanced aerospace R&D or aviation R&D organization with about 4 billion pounds of the total budget. And of course, ATI has supported a lot of work by the innovators in the hydrogen flight ecosystem, including ZeroAvia, but also some other projects that are quite well positioned in the UK. And of course, Chris is director of the Fly Zero program, which is looking over the last number of months, was looking at the top level first principles view of what clean aviation should look like. So we had Chris share some of the thoughts on that, and the quick summary of that. I'm sure there are a lot of different details that I'm missing, but liquid hydrogen is a critical fuel for the future of aviation. And then we had Pasha from Alaska Airlines. And of course, we were proud and honored to announce yesterday that we're partnering with Alaska Airlines to be the first passenger airline to fly hydrogen aircraft of large turboprop size. And we're partnering with Alaska to bring that to fruition here in the West Coast. So Pasha shared a lot of interesting details on how the operators look at hydrogen flights and clean aviation, how this would bring new opportunities to the operators. So not just make the existing business zero emission and clean, but also open up new opportunities for connectivity, new routes, new potential destinations where perhaps before excessive emissions, excessive noise, and other factors could have prevented operations. So it was good to hear that as well. And then we had a second panel, which was talking about the specific technology developments, and we had great members there. Alex from High Point working on revolutionary high temperature fuel cell technology that has a potential to dramatically increase the performance parameters of the fuel cells and therefore make it even more attractive for aviation use and deliver longer flight times and higher payloads, which is what all the operators want, cargo and passenger. We had Craig, CEO of Hyzon, which is another major fuel cell company with heavy duty applications, most notably in the heavy duty trucks. And Hyzon fuel cells of new generation have made the news over the last year or so with some third-party testing with National Renewable Energy Labs here in the US, showing them as the most energy dense, most power dense and high specific power fuel cell cores that exist. So we're happy to have Craig there as well. Hexagon, Matthew talked about the fuel storage challenges, and it was great to hear that we are getting in a pretty good shape on the gaseous storage with various technologies, getting to the performance levels that enable true commercial flights in the sub-regional segments. The 10 to 20 seat aircraft, of which there are thousands and thousands in commercial use worldwide. So this is really great to hear from this leading company that builds some of the greatest hydrogen tanks out there. And then last but not least, we had Margaret from Mitsubishi Heavy Industries Regional Jets division. And of course, we are very happy and honored to having announced earlier this week on Monday our partnership with MHIRJ on a variety of topics, including adaptation of our larger engines to the CRJ family regional jets, which are, of course, as Marge mentioned, are some of the largest segments of regional jets with over 1,000 jets operating by various operators. So this is a really exciting time for regional aviation. And Margaret had a few things to say about how exciting this future of hydrogen is for regional aviation, for MHIRJ specifically, and how we all look at all these regional operators that are flying these jets to go and transition to the new zero emission future over hopefully a relatively short period of time. We do expect these types of vehicles to be available commercially within this decade, working on hydrogen.